You are welcome to this lesson on linear programming. The objectives of this lesson will include to represent inequality in two unknown on a graph. We are also going to shade unwanted path, leaving out the path that satisfies the inequality. This inequality, students should be able to represent several of it on a single graph, and finally they should be able to make deductions from the graph that is obtained. We'll be applying our past knowledge about inequality to new situations in linear programming. Then we should be able to think interdependently using our white arts and our green arts. There are some terms that are common when you're talking about linear programming. Such terms include less than. We also have the less than or equal to, unshaded region, greater than, full lines, or what is called unbroken line. We have greater than or equal to. Yes, we have broken lines, or what is called the dashed lines, shaded region. Then when it comes to interpreting or making deductions, we use with maximum points that satisfy the inequality, and we also look at the minimum point that satisfy the in linear programming. Unlike just inequality, we can represent an inequality on a graph. This we do following some of these rules. The basic rules are that if the inequality is greater than or less than or equal to, or if it is less than or equal to, the boundary lines for the region should be drawn in solid lines, full solid lines. If the inequality is strictly less than or strictly greater than, then the boundary line for the region should be drawn as broken lines or dashed lines. And finally, we are expected to shade the regions that does not satisfy the inequality. The regions that we do not want is the part that we shade. This leaves the region that satisfy the inequality clear. We are going to look at some examples. X is greater or equal to 3. Because it is not strictly greater, there is the inequality sign there, so we are going to use solid lines. X is greater than 3, solid lines. Then we shade the unwanted part, that's x is equal to 3. Then we shade the part that does not satisfy the inequality, those area that covers 2, 1, and numbers are less than 3. The second one, y is greater than 2. This should be drawn with dashed lines. Now we shade the part that does not satisfy, that's the region below it. And thirdly, x plus y is less or equal to 8. For this equation, we need to do a table of value for x plus y is equal to 8. When x is 0, y is 8, and when x is 8, y is 0. That gives us a line that will be drawn in full line. Then for the region to shade, is because it is less than, the region above it does not satisfy the inequality, meaning the unshaded part, the unshaded triangle shows the area that satisfy those three inequalities. So we can now show coordinates. Those are the coordinates that satisfy the three inequalities. For example, 3, 5, 3, 4, 3, 3, 4, 3, 4, 4, and 4 and 5, 3. You will notice that we do not take any points on the broken lines. You don't take points on the broken lines. You only take points solid lines. The second part of the question says, for the point in part A, we should find the maximum value of 2x plus y. For the point, you put this point into a table and calculate the value for 2x plus y. Where x is 3, we bring out all our coordinates that satisfy the inequalities. Then we have, for the first one, 9. When x is 4, y is 3, it gives us 11, and so on and so forth. We could clearly see that the maximum point is obtained when x is 5 and y is 3. So the maximum for the point in which we have the maximum value is 13, and this occurs where x is 5 and y is 3. Now, making deductions from obtained regions, it is important to note that the maximum or minimum values always occur at or somewhere near the corner of the regions. We are going to use this one as a second example. The first one says we should graph the inequality x is greater or equal to 1, y is greater or equal to x, 4x plus 4y is less or equal to 40. We should show the points with integer coordinates that satisfy all the three inequalities. Remember that we are going to shade the unwanted regions. For the first inequality, x is greater or equal to 1, that will be drawn with solid lines, and we shade the region that does not satisfy the inequality. The second one, y is greater or equal to x, that gives us a diagonal, and we shade the region that does not satisfy, which is the less part. We use the table of value to find the values of x and y that satisfy that inequality. When x is 0, y will be 8, and when x is 10, y will be 0. That gives us 2 points that we plot. We use our solid lines. The part above it does not satisfy, so we have that triangle that is unshaded. Those are the points that satisfy the inequality. You can see that down. They want a point with integer coordinates. Integer means that we are going to take whole numbers only. Whole numbers only. We are not taking decimal numbers. We are not taking fractional numbers. Whole numbers only. So those are the points you see in dots. These are the coordinates you see in dots. The second part says we should find the minimum value. Don't forget that we say the minimum values or the maximum values are usually the corner point or near the corner point. So we'll take the corner points and put them on the table of values. We have taken when x is 1, y is 7, when x is 1, y is 1, and when x is 4, y is 4. Those are the three corner points. So when we plot them, the values become 31, 13, and 52. The question says we should find the minimum value, that is the smallest value. In this case, this minimum value of 13 is obtained where x is 1 and y is 1. Now we have more examples. In this case, we should be able to deduce our inequalities before plotting them. Zoe buys X lemon and Y oranges. She must buy at least 2 lemons. She must buy more oranges than lemons. She must buy a total of at least 8 lemons and oranges. The first part of the question says we should write down the 3 inequalities in terms of X and Y. She must buy at least 2 lemons, meaning she cannot buy anything less than 2. It must be more than 2. And lemons are X, so we say X is greater or equal to 2. She must buy more oranges than lemons. The number of oranges must be more than the number of lemons. That means Y must be greater than X. Y should be greater than X. She must buy a total of at least 8 lemons and oranges. The combination of oranges and lemons she must buy must be at least 8. It could be 8, it could be more than 8. It could be 8 means equal to 8, more than 8 means greater than 8. So we have X plus Y could be greater or equal to 8. These are the 3 inequalities in terms of X and Y. The second part of the question says we should graph these inequalities and show the region represented by these inequalities with the R. The first one, X is greater or equal to 2. That's it. Bold lines. We shade the part that does not satisfy. Good. Y is greater than X. We draw the line Y is equal to X because it's strictly greater than. We use dotted lines. The part that does not satisfy is the part underneath it. Then X plus Y is greater than equal to 8. We use the table of values to get that. When X is 0, Y is 8. And when X is 8, Y is 0. That gives us that. The part underneath does not satisfy the inequality. So the part that is unshaded becomes R. The third part of the question that involves deduction reasoning says a lemon costs $1 and an orange costs $2. Find the smallest amount of money that she spent. We need to look for the points that are near the corners. Remember that the maximum and minimum values always occur at or near the corners of the region. In this case, we are looking for the minimum values. We have been able to pick out 3 points there. The first one is when X is 2 and Y is 6. That will give us a total cost of $14. When X is 3, Y is 5. That will give us a total cost of $13. And when X is 4, Y is 5. That will give us a total of $14. The smallest amount therefore is $13. So find the smallest amount of money that she spent, $13. She must have bought 3 lemons and 5 oranges. That would cost $10. For more activities on linear programming, visit the link below. Thank you and have a nice time.